You know when you see a massive flock of birds in the sky, twisting and turning like it's one single living thing? Or you look at an ant colony, and they've built this incredibly complex home without anyone in charge? Well, that's what we're talking about today. It's the absolutely mesmerizing science of collective behavior, and we are about to dive right in. So that's the big question, right? How on earth do thousands of starlings, or fish, or ants coordinate so perfectly? There's no leader yelling out orders, no CEO, no queen directing all the traffic. So how is this beautiful, complex, and super intelligent behavior even possible? Well, the answer, it turns out, has nothing to do with a single leader. It's all about a collective intelligence that bubbles up from the ground up. It's not governed by some central command, but by a set of incredibly simple, almost elegant rules that each and every individual follows. And of course, scientists have a name for this: swarm intelligence, or SI for short. The term was actually coined way back in 1989 by two researchers, Gerardo Benni and Jing Wang. They needed a way to describe this amazing phenomenon, where you have these decentralized, self-organized systems of simple individuals that can somehow achieve brilliant, complex results. So, how does this magic actually happen? Well, it really just boils down to a few key ingredients. First, you start with a population of simple agents. Nobody's a genius here. Then, each of those agents follows a few very simple rules. And here's the key: their interactions are only with their immediate neighbors. There is no master plan, no one's in charge. And yet, out of all those simple, local interactions, this amazing system-wide intelligence just emerges. And no surprise here, the inspiration for all this comes straight from the natural world. I mean, scientists have spent decades looking at ant colonies, bird flocks, and schools of fish, basically trying to reverse engineer some of biology's most powerful and efficient algorithms. Okay, so the first big step was to try and decode nature's algorithm, and researchers started with one of the most hypnotic examples out there, that incredible synchronized dance of a flock of birds. The big breakthrough that happened back in 1986 with a computer program called Boids, created by a guy named Craig Reynolds. He actually proved that you could create unbelievably realistic flocking behavior on a computer screen using just a few simple instructions. This was a huge deal, and it was later fine-tuned by something called the VICSEC model, which showed that these principles were surprisingly pretty universal. And get this is the incredible part. The rules are so simple, it's almost hard to believe. Each one of these simulated Boids just follows 3 commands. 1, keep a little personal space, don't bump into your neighbors. 2, try to fly in the same general direction as the birds right around you. And 3, stick with the group, don't wander off too far. That's it. That's the whole instruction manual. And from just those 3 little local rules, you get that complex, fluid, and absolutely beautiful flocking behavior. So this discovery was way more than just a cool simulation. No way. It basically blew the doors wide open for using nature's own problem-solving strategies to tackle some of our most complicated challenges. Now, 2 of the most powerful algorithms that came out of this are ant colony optimization and particle swarm optimization. The first one, ant colony optimization, is just like it sounds. It copies how ants leave little chemical trails, right? The shorter the path to food, the stronger the scent, which guides all the other ants to the best route. It's perfect for things like logistics. The other one, particle swarm optimization, models a flock searching for something. It's fantastic for finding the very best solution when there are tons and tons of possibilities. All right, so this stuff isn't just stuck in a lab. It is out there in the real world doing some pretty amazing things. Let's take a look at just a few examples. You ever watch a movie with one of those epic battle scenes with thousands of soldiers and they all seem to be moving on their own? Well, that's swarm intelligence. They used it in The Lord of the Rings. And the same tech was even used way back to animate those creepy swarms of bats in Tim Burton's Batman Returns. It's also making your travel just a little bit smoother. Southwest Airlines actually uses swarm theory to help pilots find the best airport gates. They basically treat each pilot like an ant, looking for the most efficient path. And what happens? You get faster turnarounds and fewer delays for the entire system. Pretty cool. And it gets even more high-tech than that. The US military is looking at swarm tech to coordinate whole fleets of unmanned vehicles. And NASA is checking it out for missions to map other planets where, a whole group of simple little robots could explore a planet way more effectively than one big, complex one. But maybe the most important application, the one that really hits home, is in medicine. Seriously, these algorithms are being used to help doctors locate tumors and analyze complex things like X-rays with way more accuracy. Swarm intelligence is literally saving lives. And we're not talking about a small improvement here. A 2018 study from Stanford School of Medicine found that when they connected groups of radiologists using Swarm AI algorithms to analyze X-rays, get this, they reduced their diagnostic errors by a staggering 33%. And the impact goes even further, into really critical humanitarian work. The United Nations Food and Agriculture Organization has used this exact technology to help forecast famines in global hotspots, which lets them step in earlier and be way more effective. Okay, so where does all this go from here? Well, the next big idea, the latest evolution, is to turn the lens back on ourselves and apply these same principles, not just to robots or code, but directly to people. It's a concept called artificial swarm intelligence, or ASI. You can also think of it as human swarming. The whole idea is to connect groups of people online in real time, but instead of just having them vote, they use these algorithms that are modeled on natural swarms. It actually helps them think together, to deliberate, and to converge on solutions that are way better than what any one person could come up with alone. And you got to understand this is a huge leap past just taking a simple poll or a vote. Traditional crowdsourcing just kind of averages everyone's opinion. But AI, it creates this dynamic, real-time feedback loop. It basically turns a group of people into a unified hive mind that can amplify their collective wisdom. So if you take away just one thing from all this, let it be this. Whether we are talking about ants, birds, or even people, the core idea is exactly the same. Immense, powerful, and adaptive intelligence doesn't have to come from a single brilliant mind. It can bubble up from the simple, local interactions of many. And that leaves us with a really fascinating final thought, doesn't it? We've already seen this technology optimize our travel, create art for our movies, and even save lives. So, if we can harness the power of the swarm to solve today's really complex problems, what seemingly impossible challenges will it help us solve tomorrow?